Our entire world pretty much runs on portable power. I mean, from the phone in your hand to maybe even the car in your driveway. But have you ever actually stopped to think about the incredible chemistry that's packed into these little things? Well, today we're going to do just that. We're unlocking the science behind the power in your pocket.
I mean, really think about it for a second. It feels like magic, but it's not. It's this fascinating microscopic ballet of ions and electrons. So what is going on in there when you're doom scrolling or plugging it in to charge up? That's the question we're going to answer right now.
So here's our game plan. First, we'll dive into the world of batteries and see what makes them tick. Then, we'll see how that compares to the way we refine our traditional fuels. And finally, we're going to take a peek into the future with a technology that might just be the best of both worlds.
Okay, first things first, let's get the basics down. You see, not all batteries are created equal, and the biggest difference really comes down to one simple question. Can you recharge it, or is it one and done?
It all just boils down to chemistry. In what we call primary batteries, the chemical reaction that makes electricity is kind of like a one-way street. Once the chemicals are used up, that's it. Game over. Think of your standard remote control battery. But with secondary batteries, like the one in your phone, that chemical reaction is reversible. You can actually run a current back through it to reset the whole thing, getting it ready to go again and again.
So when engineers are designing a battery, what's the dream? What are they really chasing? Well, there are a few key things. They want high capacity, right? So you can binge watch an entire season without your screen going dark. They also want a high cycle life, meaning you can recharge it hundreds, even thousands of times before it starts to fade. And of course, a long shelf life, so it doesn't just lose all its juice sitting in a drawer.
And right now, the battery that balances all of these demands better than pretty much anything else out there is the lithium-ion battery. It is the undisputed champion of the rechargeable world, and believe me, it is absolutely everywhere. So let's get to the fun part. How does this little powerhouse actually do what it does? It's time to peel back the layers and take a look at the incredible chemical dance that makes it all possible. Okay, so every lithium-ion battery has these four key players. You've got the anode, which is the negative side. Think of it as the starting line. Then there's the cathode, the positive side, or the finish line. In between them is the electrolyte, a special liquid that lets ions move back and forth. And finally, you have the separator, which is like a referee, keeping the anode and cathode from touching but letting the ions pass through.
All right, a quick bit of lingo. When you unplug your phone and start using it, the battery begins to discharge. That's really just a fancy word for the battery doing its job, releasing all that stored chemical energy and turning it into electrical energy. So here's that chemical dance in action. The little lithium ions leave the negative anode, swim right through the electrolyte, and head to the positive cathode. But here's the brilliant part. Their partners, the electrons, can't go through the electrolyte. No way. They have to take the long way around, through all the circuits in your phone. And that flow of electrons, that is the electric current that powers your device. It's this elegant little traffic system that makes everything work. And what about when you plug your phone in to charge? It's literally that simple. The whole process just runs in reverse. The power from your wall outlet forces those ions and electrons to travel back to where they started, resetting the battery for the next time you need it. Pretty cool, right?
Okay, so we've seen how modern batteries work on this tiny, elegant, microscopic level. Now, let's zoom out, way out, and contrast that with how we get energy from one of our oldest sources, fossil fuels. This isn't a tiny dance in your pocket. This is a massive, industrial-scale process that turns crude oil into the fuel we use every day.
Refining crude oil is a major undertaking. First, you have to get rid of all the salty water that's often mixed in, and they do that with a high-voltage process. Next, you have to remove nasty stuff like sulfur. But the real main event, the most important step, is something called fractional distillation. That's where the separation magic happens.
So here's the key idea. Crude oil is just a big, messy mix of all sorts of different molecules. What refineries do is they heat it all up to about 400 degrees Celsius inside a giant tower. Everything turns to vapor and starts to rise. As it goes up, it cools down. And here's the clever bit. Different parts of the oil condense back into liquid at different temperatures. The lighter stuff with low boiling points rises way up high, while the heavier stuff condenses much lower down.
And this is what you get. A whole bunch of useful products, all from one single process. Kind of high up the tower, you get things like kerosene, which is perfect for jet fuel. A little lower down, where it's hotter, you get the heavier diesel oil. And way down at the bottom, you have the really heavy oils that are used to power massive ships or industrial furnaces.
But what do you do with all that heavy, sludgy stuff left at the bottom? You don't waste it. Refineries use another really clever process called catalytic cracking. They use heat, pressure, and a catalyst to literally crack those big, heavy molecules into smaller, lighter, and much more valuable ones, like gasoline. It's all about squeezing every last drop of value out of the crude oil.
So we've looked at the present of batteries and the industrial might of fossil fuels. But what's next? For our final section, let's take a look at a really promising alternative that kind of feels like it builds on all these ideas: the hydrogen fuel cell.
I mean, just let that sink in for a second. The entire promise of a hydrogen fuel cell can be summed up with this one incredible idea. The only thing that comes out the other end is water. You're combining hydrogen and oxygen to make electricity, and you eliminate all the harmful emissions. It's a seriously compelling vision for clean energy. And get this, it's not just clean, it is ridiculously efficient. A hydrogen fuel cell can convert anywhere from 75 to 82% of the chemical energy in its fuel directly into usable electricity. That is a huge leap in efficiency compared to a lot of the old-school combustion engines.
And the potential uses for this stuff are just vast. We're talking about everything from powering heavy transport like buses and trucks to cleaning up massive industries like steel and fertilizer manufacturing. It could even be used for generating power for the grid and heating our homes. It is a remarkably versatile way to move and store energy.
So as we look to the horizon, we've seen the advanced chemistry of today's batteries, the sheer scale of fuel refining, and the clean promise of hydrogen. The real question isn't just about which one is best, but how we'll combine them. What mix of these incredible technologies will actually end up powering our future? It's